In this video, I'm going through a worksheet that we did in class that has position times and velocity time graphs. Okay, first of all, what is the slope of a position, and displacement's nothing more than position, a position time graph, or a velocity time graph tell you? Well, all you have to do is look at displacement is x, time is seconds, time is t, and if I take that rise over run, that is equal to your velocity. So on a position time graph, the slope is velocity. And then on a velocity time graph, well, the rise is velocity, change in velocity, the time is your run, and so therefore the slope is exactly that, acceleration. So two slopes, or the same slope on both of those graphs right back here mean two different things. This is definitely telling you something different than that. In fact, this one, you are going forward at a constant rate, whereas this one, you are going faster. So the way I like to tell my students to think about it, add the unit. You went from 2 meters to 3 meters. What does that mean? You went forward. In this one, you went from 0 meters per second to 50 meters per second. You went faster. Okay, now let's look at the worksheet, the start of it. The first question, which interval is cat at rest? So it's a displacement time graph. You physically are at 3 meters if you stay here, and you are at rest. This cat was at 5 seconds, it was at 3 meters, and it stayed at 3 meters the whole time until 10 seconds. So 5 to 10 seconds. Which interval does the cat have the fastest speed? Speed is a scalar. Direction doesn't matter, so upward slope or downward slope. I'm looking just for the greatest slope. I don't care which way. And in this one, you have a slope up here. You have a flat line. You have a really great slope, the greatest slope of this right there. And then you have less of a slope right there. So the winner right here is between 10 and 15 seconds. Once again, negative doesn't matter here. But if you're answering the third question, fastest positive velocity, and really they don't have to say velocity, or positive velocity, they can just say velocity. Direction does matter, so I'm looking for the greatest number, the greatest positive number. So the fastest positive velocity would have to be this one, because none of these other ones are actually going positive. So here, right here, is the winner because it's only one. Okay, what's the acceleration from B to C? Okay, so the acceleration is nothing more than a equals change in velocity over change in time. And this guy is going 50 meters per second the entire time, so there's no acceleration. Another way to look at it is to use this. The final velocity there was 50 right here, minus the initial velocity over here, which was also 50. And the time it took to do that, it ended off at 15 seconds, and it started off at 8 seconds. And so so this ends up being 0 over 7. And so that's going to be 0 acceleration right there. Okay, what's the acceleration from A to B? So let's go ahead and do the same thing. It ended off at 50. So I'm doing this equation right here. Ended off at 50. It started at 0 meters per second. And the time it ended off at 7 seconds, and it started off at 0. Actually, no, it started off at 8. I lied. And this one probably should be like that. Okay, so it started off at 8 and ended off at 0. And when you do the work, it ends up being 50 divided by 8, and the answer is 6.25. And don't forget the unit, meters per second over seconds, or meters per second squared. Okay, now this one gets a lot of my students. Distance. This is not a position time graph. I can't read it. I'm past the position time graph. I've got velocity here. Well, you can't actually do it. What's the distance traveled between C and D? So we're looking at this interval right here, and we can get everything we need. We are looking for the distance, which, for the equation's sake, position, it could be displacement, but x works. And we're looking for a couple things. What can we get off of this graph? We can find velocities and we can find times. So we have initial velocity at C. Right when we got here, we were going 50 meters per second. Right when we got here, we were at 0. So final velocity was 0 meters per second. And the time it took, that last little interval was 5 seconds. So time equals 5 seconds. And then we can look at our handy formula sheet. And on our formula sheet, we have x equals v final, or v initial plus v final over 2 times t. And so we use this equation right here. We go 50 plus 0. Watch out, there's some other equations that have negatives there. Divided by 2 times 5. And we get 50 divided by 2 times 5, 125 meters. Okay, so let's go ahead and move on to the next one. What information would the slope of this graph give you? Okay, once again, velocity over time. This is going to give you acceleration, which is equal to the change in velocity over change in time. So rise over run. What's the slope from A to B? Okay, more of the same. A equals change in V. Here we get to 15 from 0, and the time it takes is 10 seconds. So it's going to be 1.5 meters per second squared. Don't forget the acceleration unit. Okay, what's the distance traveled from B to C? Okay, so here, oh, look at this. It is a constant velocity. So either you can use VI as 15 and VF as 15, or you can just say straight up V equals 15 meters per second. We are asked for the displacement or distance here. The direction doesn't matter, but you still would solve it the same way. And we also need the time, which we can catch off of here. So time equals 15 minus 10, which is 5 seconds. So now we have v equals x over t. Rearrange that for x. X equals v times t. And that ends up being 15 times 5. And that ends up being, times 5, 75 meters. So that's the distance traveled in this question. Okay, what's the slope from C to D? Okay, so what is the acceleration from C to D? Acceleration is, you ended off at 30. You started off at 15 meters per second. The time it took was 5 seconds, or 20 minus 15. And so you get 15 divided by 5, or 3 meters per second squared. Okay, so let's finish off some of these. Here, which interval is the car accelerating from rest? Okay, so I'm looking for, it's a velocity time graph. The only place I'm at rest is when I'm at 0, right there. I'm accelerating, I'm getting faster and faster and faster and faster. So this is going to be interval A, from 0 to 4 seconds. Which interval does the car have negative acceleration? It's where I'm slowing down. I'm going from 12 meters per second to, it looks like 6 meters per second. And that's going to be interval C. How far does the car travel during B? Okay, so I have to do some math. How far does it travel? I'm going to use X. And then I'm going to go ahead and during interval B, the time for interval B, let's see, it's 9 minus, it looks like 4. So it looks like it took 5 seconds. And I can also get the velocity. I was going 12. So our velocity was 12 meters per second, and it stayed there the whole time. So v equals x over t rearranges to x equals v times t. And v is 12, t is 5, and our answer here would be 60 meters per second. Or sorry, 60 meters, not 60 meters per second. Sorry, I was getting a phone call. 60 meters. Okay, so now if you're going to calculate acceleration for A, you are going to your acceleration is going to be the slope of these lines. So A equals, and if I'm going to do it mathematically, A equals change in V over change in T. So this first slope, you go 12 meters per second faster, and it takes you 4 seconds. So that will be 3 meters per second squared. So 3 meters per second squared. For B, you're not changing your velocity, so there's 0 meters per second squared is your acceleration, no acceleration. C, you are going, and you're going slower and slower and slower, so you're decelerating, but let's figure out how much. You end off at 6, you start at 12, so you go minus 6, your change in velocity is minus 6, and the time that it takes is, so you're at 9, 10, 11, 2 seconds. So this is going to be -3 meters per second squared. And then D is going to have a positive acceleration. So the change in velocity here, you go from 6 to, so you're right here at 6 and you go to 10. So you go faster by 4 meters per second. And the time it takes is your 11, 12, 11, 12, 13, 14, 15. So 1, 2, 3, 4. Takes you 4 seconds to do this. So you have 1 meter per second squared. That's your acceleration. Okay, so let's look at the last question. We have a position time graph. So you need to make sure you recognize that first. What's happening during each interval? You are at it looks like about 10 meters the whole time, and you stayed at 10 meters. You're at rest. You were at 10 meters, and you started going forward, but faster and faster and faster. You're accelerating in the second interval. The third one, you're going forward at a constant rate. Somehow you started going faster all of a sudden, but then you started slowing down. The slope started decreasing. And once again, the slope on a position time graph is velocity. Then you stayed at 60 meters the entire time, and then you started going backwards at a constant rate or constant velocity backwards. Hope this helps. Thank you.